Okay, so we have set up our Postgres database with the schema that we generated in a code-first fashion using Entity Framework with the models that we defined for our API. So we've got customers, orders, and servers represented in our database as tables. And we defined an API context, which extends our DB context and contains our DB sets for each of those entity models. And this is what Entity Framework uses to sort of represent the session with our database. And the DB context here that we've defined will be what we use to interact with our database in our code. So now let's go ahead and write some code to seed our database with some sample data when we start our application. So the way this is going to work is I'm going to go ahead and create a data seed class. And that class will be responsible for actually running all of those, all the commands that we need to populate our empty database with some new sample data. So I'm going to go ahead and right click in our project and create a new file called dataseed.cs. And the namespace will be advantage.api. And we'll have a public class dataseed here. So let's create a reference to our API context. And so we'll do that. We'll create a field here, private field, private read only API context, and underscore CTX for context. And then in the constructor for our data seed, we'll pass an API context here. And then we'll set the value of that field to the context that we pass our data seed. So to use API context, we can control period and bring in our models namespace, which is where that context is defined. And then we'll create a method called seed data. So this will be the only public method in our data seed class for now. So let's say public void seed data. And let's think for a minute here about what we want to get out of our seed data method. We're going to populate some number of sample customers, orders, and server objects in our database. This is, of course, just to have something to query against and something to represent in our front-end application as we're developing against it. And so we'll have some specified number of customers and orders, and then some set of objects to represent our servers inserted into tables in our database. So in our data seed method, I think I'd like to pass as arguments here an integer number of customers as well as an int number of orders. Our server objects will be represented sort of just as a static list that we define, whereas our customers and orders we're going to kind of programmatically generate, creating some sort of randomized customer names and randomized orders. And so let's look at how we're going to do that. First of all, we only want to populate our database if we don't have some existing data in it. And so what we'll do is we'll say if not context.customers.any. In other words, if there are no customers in our database. And to use .any, we need to bring in link. So we'll import link here using system.link. So if there are no customers in our database, then we'll write a method to seed customers, and we'll pass it n customers that we passed our seed data method. So if we want to generate, say, 20 customers, then we'll pass 20 as the first argument to seed data, and then seed customers will take that value and then essentially generate 20 random customers. And then here we'll call context.saveChanges. And I won't go too in-depth about .NET Core and Entity Framework here, but essentially what we can keep in mind here is that save changes, in a sense, commits our changes against the database. And so it's the command that actually sort of runs that insert statement. We'll see in a moment here, inside of our seed customers method, we'll be running a context.add method, which will start tracking some of our entities for insert into our database. So nothing actually happens against our Postgres database until save changes is called. And up until that point, Entity Framework is just tracking certain records that we're either adding, updating, or deleting in our database. So likewise, we'll have similar methods here for orders and servers. So I'll just go ahead and paste 2 more. So we'll have a method seed orders, and we'll have a method seed servers. And in fact, we could probably just call save changes once after each of these operations has completed. And of course, we need to check for the relevant type. So orders and servers. So if we don't have any customers, seed them. If we don't have any orders, seed them, and likewise for servers. And then once that's complete, we save changes, and Entity Framework performs that insert or set of inserts against our database to save our data. So let's think about our seed customers method first. We'll go ahead and create that here. So it'll just be a void method seed customers, and it takes our end customers in as its only argument. And so let's go ahead and create a var customers. And what we'll do with that is essentially write a method to build out our customer list. And we'll pass this n, once again, to pass in the number of customers that we'd like to build. And just to be clear, our customers is a list of customer objects. And so we'll control period to bring in system collections.generic. And so now we can build this build customer list. But let's assume that we've built it and we've got our list of customers back from the database. Then what I can do is just iterate over that list with a for each, and we'll say var customer in customers. And now we'll say ctx.customers.add customer. And so what this is going to do is, of course, add to our customer collection in our DB context for every customer in the list that we build. So that's pretty straightforward. Now let's go ahead and figure out how we're going to build this customer list. So we'll go ahead and create a method for that here. Private list of customer, build customer list. We could work with enumerables here as well, and then call toList in our seed customers method, but for now we'll just keep it like this. And so we'll pass this once again in customers. And this is where things can kind of start to get interesting and a little creative. So first of all, we'll have our customer list here, which is what we'll ultimately add to and then return. So we've got a new list of customer. And I forgot the equal sign here. So we'll new up a list of customer objects. And then what we want to do is create some number of customers, setting their primary key ID, a name, an email, and a state for them. And so state here, once again, is sort of a way to represent their address. So of course, feel free to change this property or any properties on these models as you build out these methods. So back here, we have our list of customers in our data seed. And now let's figure out a way to sort of generate each of those properties in a way that we can create a number of unique customers in our database. So we'll have a for loop here. And so what I'll say is for var I is equal to 1, I less than or equal to n, I plus plus. Where n here is n customers, I should say. Then we'll add a new customer to our customers list. So we'll call .add on customers, and to that we'll add a new customer, and we'll set their primary key ID just equal to I, which is why we start with 1 here, so that our first customer that we add to the database has a primary key of 1. And then we'll have to come up with some way to assign them a name and an email here, as well as their state property. So let's think about how we're going to set these up, because we want to generate sort of a pseudo-random name for our customers and have some corresponding email address, and then the state will just be, we want to select a random state, maybe from a list of state 2-letter codes. So let's go ahead and store the name in a var here, and we'll do that inside the for loop. So say var name, And then let's go ahead and create a helper class. We'll call this helpers, and we'll say .make customer name. So I'm going to store this make customer name method and anything else that we need to use to sort of build out names and emails and that sort of thing in a helper class, and try to maintain some separation of concerns here, where our data seed class is more or less concerned with getting some objects to actually insert into the database. So I'm going to right click in our project here, create a new file called helpers.cs, and this will just be sort of helper methods. So once again, our namespace here will be advantage.api, and we'll have a public class helpers. And so let's go ahead and create that static method make customer name on our helpers class. So we'll just make an internal static string make customer name. And so we know ultimately we're going to be returning a string here. So let's think about how we're going to kind of build that string out. Well, I think one kind of sort of creative way to do this is to store a list of business name prefixes and suffixes, and then sort of randomly combine those two things to create sort of unique business names. Since we're kind of imagining our application as serving a sort of business-to-business type enterprise, then we'll have a set of business prefixes and business suffixes to compose unique business names. So we'll go ahead and build that out, but keep in mind you could use the same kind of setup that we're about to build to generate like unique usernames or anything else like that. So we'll have some var prefix, and we'll write a method to get a random prefix from some list of business prefixes, which I'll just abbreviate here with biz prefix. Likewise, we'll have a suffix. And then we'll return prefix plus suffix. Okay, so we have some more things to define here. How are we going to get a random element from a list? Well, let's go ahead and define that here. We'll have a private static string get random, and this will take something that implements a list anyway of strings called items. And if we were going to use this for more than just list of strings, then we could definitely kind of refactor this out into a more generic type method that could return a random element from a list of any particular type. But since we'll just be using it for strings here, we'll just keep it as is for now. And so let's make a var rand, and we'll set that to a new random. And random is an object that we can call .next on to get a random integer from. Let's go ahead and bring random in. So we'll need to be using system. And so what we can do is, since we can generate a random integer within a specified range, then we can actually select a sort of random index from a list of strings. So what we can do is very simple here. We'll just go ahead and return items, and then we'll say rand.next, and we can pass next the maximum integer value that it will return, so from 0 to this integer value, and that maximum value will always be the length of the number of items that we have. So we can just say items.count here, and we'll bring in collections as well here. So you can kind of see how this is going to work. We have a new instance of our random class. We have a new instance of C#'s random, and we're going to return the item at a random index for a list of items that we pass get random. And we set an upper bound on the value of the random integer that we return by passing it the length of that list. So we'll never get an index out of range exception here. I think I'd like to also pull random out here because we'll be using it elsewhere in this class, and we'll just create it a field for it and set it here in the class. So we'll have a private static random, and underscore rand is a new random, and then we can just use that reference here in our get random method. Okay, so we have a way to get a random string from a list of strings. And so now let's create those list of strings for business prefixes and suffixes. So I'm just going to create a private static read-only list of strings, biz prefix, which is a new list of string. And this is where you can kind of get creative and create a list of fictitious business prefixes. So we'll just create a handful of those here. And then likewise, we'll create a fictitious list of business suffixes. And so feel free to customize these to your own choosing, of course. All right, so we've got a list of sort of business types as our suffixes, and maybe just a few business prefixes here, so that when we combine these in some random fashion, we get some sort of unique business names. Now we could put some additional checks in here to sort of control for unique names where we use make customer name, but we'll take care of that in our actual data seed. So we'll head back into our data seed, and here we have our list of customers. And so now we have a way to actually make the customer name. So we'll make a random customer name using our helper method. We'll assign that to the customer in this particular iteration. Now let's figure out a way to make a customer email. So we could put just some, any old value in here, but I think to keep things interesting, we'll create a helper method to make a customer email, and we'll pass the customer name to this method to have a sort of corresponding email for the customer's company name. So we'll go ahead and head back into our helpers and create a method, internal static method, make customer email, and we'll pass this a string customer name. So we won't get too complicated here with this, but what we'll do is just simply return, and then we'll use some string interpolation here to build the email string, and we'll just say contact at customer name, and we'll call it toLower on it .com. Okay, so back in our data seed, the last thing that we have to do is to get a random state. Let's create a helper method for that, and we'll say helpers.getRandomState. And so we'll head back into our helper methods here and make an internal static string getRandomState. And so for this, we'll create a private static read-only list of strings. This will be US states, which is a new list of string. And again, the only reason I'm doing this is just for the sake of simplicity. If you'd like to generate random addresses of a different type or use states from another country, then of course you could do that here. So for the sake of time, I'm going to go ahead and just copy and paste the state codes for the 50 US states. And I realize that there are a few others for outlying areas and DC, but all this is just more or less for the sake of generating some sample data, so we'll just leave the 50 state codes here. So now getRandomState is simply going to implement our getRandom method, and we'll pass it the US states, which is a list of these codes, and we can go ahead and return the result from that method. So this is going to return a random string corresponding to one of the strings in this list, and we use that in our data seed to actually get the random state for this customer. Okay, and if we wanted to make sure that we were making a unique customer name, then we can kind of modify this make customer name method. We won't get too complex here. We should probably have a separate method to make a unique customer name. But in short, we can just kind of build out a very simple version here by having a var names as a new list of strings. And then when we make a customer name, we'll pass it that list of names. Of course, we'll have to modify our make customer name method. Let's call it make unique customer name. And then we'll add our name to our names collection here. So we'll just go ahead and say names.addName. And so now we can just brute force check the unique name that's created against the list of names and kind of call it recursively until it generates a name that's not in this collection. So let's go ahead and head back into our helpers, and we'll change make customer name to make unique customer name. Again, you could refactor this out into two separate methods. So we have a list of string names that we pass it now. And what we'll do here is basically just do a brute force check. So we'll say if names dot contains full name, which we'll define here as prefix plus suffix. And maybe for the sake of naming convention here, we'll call this biz name prefix plus suffix. And what we'll say is if the names already contains biz name, then we'll recursively call make unique customer name again, passing it the same array. So this is obviously a little bit dangerous because we're using recursion here. So if we were being thorough, we should also have a check here to basically ensure that we don't call this recursively if the length of all the names is equal to the maximum possible combination of unique names from our set. We'll avoid that for now, although it would be a good idea to implement if you're going to generate lots of random customers. So let's try to mitigate that risk by throwing an exception when the list of names is equal to the maximum number of permutations, or I should say combinations of business prefixes with suffixes. So we should be able to do that pretty easily here. We can say var max names is equal to biz prefix dot count times biz suffix dot count. And then what we can say is if names dot count is equal to max names, and just for extra safety here, we can say is greater than or equal to max names. And we'll just throw, say, a invalid operation exception, and we'll say maximum number of unique names exceeded. So we shouldn't get into the case, this case as long as when we're generating n number of customer names, we don't pass it some value that exceeds max names here. But this method is still potentially expensive considering the fact that we are using recursion here. But once again, it should suffice for our simple use case. So let's head back into our data seed. And now that we've built the customer list, we can simply return it. And so you can see that what will happen here is we pass build customer list an integer number of customers. We new up that list. We create a var names in which we can store the names that we randomly generate. And then for var I in the range of n customers, we generate a unique customer name. We add it to the list of names. And then to our customers list, we add a new instance of a customer who has that ID, name, email, and state. And then we return our list of customers here, back up to our seed customers method, which then iterates through each of those customers and adds them to our database. So now let's go ahead and seed our orders. So we'll go ahead and create that method, private void seed orders, again passing it an int n, and we'll follow much the same structure that we did for seeding our customer types. This time, of course, we'll create a list of orders, and we'll have a method build order list. And so then for each var order in those orders, we'll go ahead and add that order to our database. And of course, we need to make sure that we're adding that to orders and not customer. Okay, so let's go ahead and create our build order list method. So we'll create that just below our build customer list. Pass that an integer value and orders. And so we'll store our orders in a new list of order objects. And we'll scroll down a bit here. And so now, once again, for var I is equal to 1, I less than or equal to n orders, I plus plus, we're going to add a new order to our orders array. And so the ID will be I. The customer object on this, we'll write a helper method to get a random customer. The order total amount here, we'll use the helpers to get a random order total. Placed, we will create a method for that as well and store it in a placed variable, likewise for completed. And so what I'm going to do with placed and completed is let's work on those first, since they're the most interesting. So we'll have a var placed, and we'll write a helper method to get a random order placed. And this needs to, of course, be inside of our for loop here. So go ahead and clean this up a bit. And the reason that I am putting placed in a variable here outside of our add method is because we need to use placed to determine when that order was completed. So we'll say get random order completed, placed. Because of course our completed date can be only after the order was placed, and we actually want to make some of the orders completed on, and we actually want to make some of the completed dates to actually be null, and we'll take a look at that here in a moment. And that is again to represent sort of a more realistic state for our data in which orders which were recently placed or placed within some defined window of time would not yet have been completed. So we'll handle that as well. So let's think about getting a random customer first. So to do that, we would obviously need customers in our database. So the order in which we seed entities in our database is important. It would also require those changes to have been committed to our database. And so I think our context.save changes should be called before we try to generate random orders, because the orders depend on there being some customer to link to. And so the order of our data seed matters here. So we need some customers in our context before we can create orders for them. So let's go down here, and what we could do is we could pass our DB context here as an argument to get random customer, and then inside of our helper methods query for all the customers and then return a random customer from that list. But let's just do that in place here perhaps. So rather than have a get random customer method, what I'm going to do is say ctx.customers.where, and we can say like the customer, which I'll just abbreviate as C for the lambda here, c.id is equal to rand customer ID. And then in build order list here, I'll have a var rand is a new random, and we'll bring in system for this. And then here var rand customer ID is equal to rand.next, and here we'll call ctx.customers.count. And so this random customer ID will return a random integer between 1 and the number of customers in our context. And then so when we add that customer, we will assign it to the customers where the customer ID is equal to that integer, and we can just call first here rather than where. And so that will return the first instance. And in this case, that would be the only instance where a customer has a particular primary key. Okay, so that should work. Now let's take a look at this helper method, getRandomOrderTotal. That should be pretty straightforward. So in our helpers, we'll create a new method here. Internal static getRandomOrderTotal. And sorry, this is a decimal. And for the sake of simplicity, even though this is a decimal, all I'm going to do here is return rand.next and then some value between say 100 and 5,000. Okay, so we'll head back into our data C that takes care of the random order total. Alright, so now we'll think about how to get a sort of random date that an order was placed, as well as a nullable random order completed date.